Today we're learning how to write linear equations in standard form. Standard form is slightly different from slope-intercept form. It generally looks something like this, where A, B, and C are integers. Now, sometimes we're going to start with a different form, like point-slope form or slope-intercept form, and convert it to standard form because that's the easiest way to find the equation. Sometimes we'll go straight to standard form based on a word problem or a similar situation that gives us standard form, but we'll cover that more tomorrow. Today we want to look at just writing the equations themselves and pulling them from a given graph. So the first thing the book gives us is they give us one equation in standard form, and they want us to write two equivalent equations. Now the way we come up with an equivalent equation is very simple. We multiply or divide the equation by any number, but we want to stick with integers, that is whole numbers, positive or negative. So if we're going to divide by a number, we want to make sure we divide by a number that gives us integers. So in this case, each of these numbers is divisible by 2. So what I can do is divide the whole equation by 2. That's equivalent to dividing the 2x by 2, dividing the 6y by 2, and dividing the 4 by 2. 2x divided by 2 is x. Negative 6y divided by 2 is negative 3y. And 4 divided by 2 is 2. So that is one equivalent equation. Another way I can get all integers is just to multiply my equation by any integer, say 7. 7 times 2x minus 6y equals 4, I can just use my distributive property. I get 14x minus 42y, and then since I multiplied the left side by 7, I've got to multiply the right side by 7, which gives me 28. Now, since we're not limited in the numbers that we can multiply the equation by, we're not limited in the number of equations we can get. So we can get an infinite number of equations that are equivalent to our original equation. So these are just two of the many possible equations we could get. Another one we could get is to simply multiply both sides by -1. If we do that, it basically just changes every sign in the equation. So it becomes negative 2x positive 6y equals negative 4. There's another equivalent equation. So for your homework, you're going to be asked to write equivalent equations. That's essentially what we do. We multiply by another whole number or divide by a whole number that leaves us with whole numbers. The other issue we're going to be given is we're going to have a graph of a line with 2 points, and we need to find the standard form of the equation on that line. So we can start with either point-slope or slope-intercept form. Now in this case, since I don't have the y-intercept given to me, it's easiest to use point-slope form. First, we need to find the slope. So we're going to do our change in y, which is one of the y's minus the other y, over change in x, and we start with the same point, 2, subtract the other one. So we get negative 3 on top, positive 1 on bottom, which reduces to negative 3. So we're going to plug that into our point-slope form, which if you remember was y minus y1 equals m times x minus x1. So we plug in the slope for m, one of the x's for x1, about 1, and the y that goes with that, x, for y1. Okay. So these both come from the same point. Now in order to get in standard form, what we want to do is we want to first use the distributive property on the right, and then we're going to move the constants, that is the numbers without variables, to one side, and the variables to the other side. So we're going to add 3x to both sides, and add 1 to both sides. That gives me 3x plus y equals 4. Now what I want to do is I want to make sure that this is the simplest form of the equation. So is there any number that goes into 3, 1, and 4 evenly? No. If there was, I would divide the equation by that number just to kind of reduce it down. Like we did in the last problem, we brought the 2x minus 6y equals 4 down to these terms. That would be the lowest terms. Now I'm going to give you 2 points, and I want you to write them, write an equation that passes through those 2 points in standard form. So the points are 3, negative 1, and 2, negative 3. So take a few minutes, walk through the problem, and then when you're done, hit play again, and we'll walk through it together. So our first step is to find the slope. So let's go in the other order this time. We'll start with negative 1 and 3. So we'll do negative 1 on top, 3 on bottom. Then we're subtracting the negative 3 and 2. So minus a negative 3 and minus 2. So on top, negative 1 minus negative 3 gives us positive 2. And 3 minus 2 on the bottom gives us positive 1. So our slope is 2. So when we plug this into slope-intercept form, let's plug in the second point, the 2, negative 3. So we got y minus negative 3 equals 2 times x minus 2. Use our distributive property and simplify. That gives us y plus 3 equals 2x minus 4. Then we want to add 4 to both, we're going to leave the 4 where it is. We're going to subtract 2x from both sides and subtract 3 from both sides. That will get the constants, the numbers without the variables, on one side, giving us negative 7, and the terms with the variables on the other side. And we check, is there any number that can go into 2, 1, and negative 7 besides 1? No, there's not. So that's our simplest form of our equation. Alright, if you have any questions, feel free to ask. You can go back and watch the video again if you need something clarified. Otherwise, you can move on to your homework.